so don't worry. And also, I will write on the paper or on the whiteboard, which mode you prepare on the paper or paper? Okay, and then scan it and upload it to the system. Focus on the notes. Good. All important notes on the page. Okay? Don't worry about the book or because the book gives the fake light. No, I will give you all details on the paper. Okay? So focus on this one. This class is you can use your lecture notes in the exam, okay? Because you are graduate, okay? Also, you can use your lecture note, okay? I prepare to print out the lecture notes, okay? Each week, okay? To prepare to the exam, okay? Don't use the mobile as calculator or computer. Only use the paper and the exam. Okay. Other recommended textbook is my book. Okay. Don't worry about this one. It's Amazon. I'm sorry, but just I want to show you this book. Okay. Fundamental of Electric Power System. I will give you the chapters, 1 or 2 chapters from this book. And another book, this one also, my book, Advanced Power System. Also, I will give you some sections from this book. Okay? Please, if you want any book or reference, let me know. I will give you hard copy or soft copy. Don't purchase or order any book. Okay? Especially my books, I will give you.
You say hard copy?
If I have hard copy, I will give you a hard copy.
Just give like
Yeah, no,
like a
no,
hand?
not for you. Return at the end of the semester, but or if you want, give you the draft as PDF, draft of the book, or some books I have the final edition. I can send you. Okay, no problem. Okay, but no purchase any. Don't pay any money. Okay, please. Also, if you maybe I will ask you about the project to do report, 1 or 2 pages report at the end of the semester. You can go to the library website for prior view INM. You can download from IEEE all IEEE journals, conference, magazine, and other type of publishing free and prior view IIM University website. Okay, you can go to prior view IIM University. I will show you also today where and how to come to download the papers. When you finish this course, should be able to know the types of energy sources and applications requirements and analyze energy types, compare the different type of energy equivalent circuit and their characteristics, maybe characteristic between power and current, maybe voltage and current and voltage, or okay, we can learn this semester all these characteristics for wind turbine, for solar cell, or for hydro. Be able to understand an operational characteristic of various energy sources. Today we will learn what is meant by various energy sources. And design, construct, and integrate various energy sources in microgrid, and to be able to piecewise or MATLAB to solve equivalent. And this point, I will explain it maybe in the computer lab, MATLAB program, simulation program with renewable energy sources, and we will use Upstairs lab, power lab, room number 215. We will use renewable energy sources, hydro, wind turbine, and solar cell, or battery charger source. Now, grades for this course determined from 5% attendance and participation, 15% assignment, 10% design project, exam 1 and exam 2 20%. Exam 1 and exam 2, we have 2 exams in this course. First exam before midterm exam, and second exam before final exam. I will count highest grade of them and cancel the lowest one. And so now we have 1 exam of 2. And we have midterm exam 20% and final exam 30%. Maybe I will move 5 grade from exams 1 and 2 to assignments. To be assignments 20% and exam 1, 2. I will check your grade. Okay in the exam? No. I want to help you. Please help yourself. Okay?
Is the design project or a final project?
Design a project at the end of the semester, maybe a report and design some renewable energy sources with the MATLAB or SCADA system. Okay, depend on the our materials this semester. If we have time, we will do 1 or 2 experiments in Upstairs lab. Okay, or by MATLAB, I can explain it here, or the computer lab, explain MATLAB simulation with renewable energy. Okay, and just I want to write report about it. No problem, because I know we don't have time to learn the MATLAB, all functions for MATLAB during this semester, or all SCADA, because MATLAB or SCADA, or either for research open time, okay, or for specific course, MATLAB course or SCADA course, okay, we need a lot of time. But I will explain all fundamentals components. If you remember, for 2 years we did packet tracer, Cisco packet tracer, okay, with network. You did project, okay, but just depend on our class, not all the network system. No, just renewable wind turbine and solar cell connected to the system. That's it. Okay, so don't worry about the project design. The criterion for the grade A from 90 to 100, B 80 to 89, C, D, F 70, 60, 0 to 15. Okay, I hope to get A or B. No, C or D. Okay, but depend on yourself to study. Now, computer application, we say MATLAB. Okay, and design project, we will discuss this one next time. Okay, we will discuss the design project. Okay, next time. the syllabus for the class for this topic. Week 1 today should be introduce the energy and modern designing energy as solar cell, wind turbine, hydro. I will explain it today. Next week we will continue with electric power system basic. We will discuss the history of the USA grid and energy sources, location of the power station, and assignment. I will give you assignment next week, not this week. Okay, we will start with assignment next week. Okay. Week 3, source of energy. Source of energy. Sun. Wind, source of energy. Water, source of energy. Okay. Now we're speaking about renewable energy, not non-renewable energy. Non-renewable energy as thermal plant or gas plant or no. We speaking about renewable energy. Renewable, sun, wind, hydro, water. Okay. We will learn all of these here. Okay. Solar thermal energy and photovoltaic. Today we will know there is a difference between solar thermal energy and photovoltaic. Different. Yeah. So we will learn this one. We will study a equivalent circuit model for ideal and practical. For ideal, without resistor, with ideal without resistor, and practical with resistor and voltage drop across the diode. 0.7 silicon, 0.3 germanium. Now, solar thermal energy and photovoltaic continue. Week 5 and exam 1. I prepared to shift exam 1 before midterm exam, not in week 4. Okay, to take the exam in all material from the first week to week number 6. Okay, 6 weeks. Okay, this review for the midterm exam. Okay, this will be review for midterm exam. Okay, so I prepared should the first exam before midterm exam week 7. Okay, and we can shift some material week 4. Solar thermal energy and photovoltaic continue week 5. We will design solar cell system this week. The design is very important. At least 1 or 2 questions. First and midterm exam, design solar cell. For the final, design wind turbine. Design wind turbine and measure the power flow of wind turbine. So we need to study the power flow in the system. Okay, we will use fast decoupled load flow, easy method, iteration method, but we will take just 1 iteration. Also, I will run MATLAB program using fast decoupled to show you the power flow in the system using wind turbine or using solar cell. Solar cells generate DC output, right? The output of the solar cell DC, not AC. Wind turbine AC. So we need inverter to convert DC output from the solar cell to AC. The inverter may be single phase or 3 phase, depending on the rating required. So So we need to study the inverter because we will design solar cell system started from the irradiation and temperature and to the load. The input of the solar cell, irradiation and temperature, converted to output power voltage and current, or voltage time current power, output power, but DC power, then converted to AC by inverter, then AC connected to the load. But I don't know if the load single phase or three phase. Should we design the load? So I will give you the data of the load and start to design from the beginning to the load. Okay, or start from the load to the okay. This is design for solar cell. For wind turbine, the output of wind turbine AC. AC, variable AC. Why? Because wind turbine depend on the wind speed, wind direction, wind pressure, or air pressure. Okay, so variable. Variable wind pressure, variable. So we'll give variable voltage, variable frequency. So we need to get voltage constant at 120 volts and the frequency at 60 hertz. So we will connect the output of the wind turbine to the rectifier to convert it to DC, then from DC to AC inverter to get a fixed AC voltage and fixed frequency. All these concepts we'll discuss in this class. Okay? Don't worry, now I don't need to write anything. I will write everything on the lecture note, so don't worry. Again, power wind generation continue week 7, week 8, midterm exam. I think after midterm exam, 1 week holiday or no? No, spring, yes, spring, okay? No, okay, so, yeah, Thanksgiving at the November, yes.
So no break?
November,
We don't break.
no,
We don't break.
no break, it's just November, 27, 28, before the final exam. Week 9, bioenergy, also we will know what is mean by bioenergy, biomass resources, biochemical conversion technologies, thermodynamic. Thermodynamic is very important. Thermodynamic class is very important for electrical engineering. Why? Because part of power generation in the renewable energy, one source of renewable energy. So thermodynamic is very important. Plus thermochemical conversion technologies, bioenergy systems, environmental impact of the bioenergy and economic and policy. Hydroelectric power sources, this is very important. We will study the design of hydropower sources and economic dispatch of this type, because it's very important. Economic dispatch, like economic dispatch, fuel cost, fuel, hydro no cost, because the water power, no, but we will discuss this concept, what the cost of this type. But the cost, money spent in hydropower sources or hydropower system. Total energy, very important, but this is, I will show you now here source of renewable energy. Wave energy, also ocean wave dynamic and wave formation and characteristic wave energy and conversion technologies we will study in this week. Geothermal energy, it's very important. But see, the USA, most renewable energy, solar cell, wind turbine. Okay, I will show you the curve today, for today. Okay, update, and this website is very important for you to understand the renewable energy and traditional energy. I will show you today. Okay, integration renewable energy with microgrid with a smart grid, micro and smart grid with the traditional power system. We will study in week 14, week 15 project presentation and review this one and exam 2. Okay, review and exam 2 for final exam and 16 final exam, or maybe we will miss 1 week Thanksgiving holiday, I think 26 or 28, 27 holiday is okay now. But we will cover all the materials of the sequence, okay? Student support and succeed, you know the location of the library, okay? If you need any hard copy book, or if you want to print out the lectures or any free, okay, I think $120 free per semester for each student, okay? You can print out in the library, okay? And this can be rules and different points about pandemic and about now, let us start first the introduction for renewable energy sources. Most students here, I think you know my questions is just calculate, determine, okay? No explain. Why? Because explain, okay, explain it's open book, you can copy paste, you know, so design, okay? So each exam consists of 4 questions, answer 3. 4 questions, answer 3, okay? So, or if ask you about concept of the questions, of the results, discuss the results, comment on the results, draw the results, draw the relation, draw the design for solar cell or for wind, okay? No copy paste. So today, just the concept of renewable energy and types of renewable energy sources. What is meant by energy? Energy is the ability of the system to convert from one form to other form, as from mechanical form to heat, friction, or from electrical to mechanical, motor. It's energy, okay? This energy, it can convert it from one form to another, but cannot be created, according to what? Law of conservation of energy. So you cannot create the energy, but you can convert the energy from form to other form, from mechanical to electric, from electric to heat, from electric to mechanical, to chemical, from chemical to electric, battery, chemical, convert the chemical energy to electric, plus minus terminals of the battery. This is converted from chemical to electric. Okay, so now type of energy, mechanical energy, conversion energy or motion or position, motion or position, rotation maybe, or linear, depend. For example, moving car or lifting and objective involved. Converted to various forms, such as electric energy, from mechanical to electric. What the component in our system convert the mechanical to electric?
The
Generator. Generator, prime mover connected to generator. Prime mover, generator. Set of prime mover generator, turbo generator, called turbo generator. Turbo generator convert mechanical to electric. Okay. Electric energy convert electric energy, electric current, electric voltage, electric power to light, to thermal, to mechanical, okay, or electrical to electrical, but in another form. Electrical continuous to discontinuous, or discontinuous to continuous, okay? So this one. Thermal energy, thermal conversion, heat energy. Yeah, heat energy due to maybe friction. It's heat energy. Heat energy is can produced by burning fuels or through friction, converted to mechanical energy. Steam engine. Steam engine. Okay. Electric energy, thermoelectric generator, directly. And chemical energy storage, chemical bonds as relates to through chemical reactions, thermal energy or electrical energy or mechanical energy can convert form. Okay, and radiant energy, electromagnetic waves such as sunlight to energy, electric energy, solar panel or thermal energy, solar heating. See, we have two types: electrical energy, solar panels, and solar heating. We have two: heating and solar panels. Upstairs lab have solar panel. Okay. Solar heating, heater. Okay. Maybe some if you have home solar heating, if not gas or no heater. Okay. Solar heating or chemical energy. Okay. These types of energy available, okay, or most energy used. Now, renewable energy. This section energy. This section renewable energy. Renewable energy. What is mean by renewable energy? Is energy derived from natural sources? Natural sources are some water, okay, wind, okay, and this environmentally friendly compared with non-renewable energy. Yes, because no heat, no radiation, okay, no population, no dust, okay. So this is friendly or green sources. Green sources or friendly sources. Not saying non-renewable energy. Renewable energy, thermal energy. You can see on the way the thermal smoking on the out of the water from the boilers goes to the sea or goes to the another location. So dirty sources. Now, solar energy conversion, convert sunlight into electricity using photovoltaic panels. Okay, I will show you today the panels of the solar cell. Okay, converted to electricity or heat. Electricity, voltage, positive, negative terminal, DC, output, or heat. Okay. Wind energy, convert the kinetic energy of wind into electricity using wind turbine. Wind turbine consists of the or double feed IG. IG mean induction generator. I am induction motor. IG induction generator. Double feed. Why double feed? After the break, we will go to the lab. I will explain it what is mean by double feed. Okay, double feed, the generator or motor, see, generator or motor, but we say wind energy, generate power, yes. This motor may be working as generator or maybe working as motor. When we use or work as generator and when we'll use as motor, I will explain today. Okay, generator or motor feed from the stator and rotor, so it's called double feed IG or double feed induction generator. Okay, so the generator feed from two sides, from the rotor and stator. Why from rotor and the stator? They will know why. Hydro power or hydroelectric power or hydro water convert the kinetic energy of the following water from rivers or dams into electricity using turbines. We have two types of turbines for hydro. Okay, two types of turbine of hydro. Two types. Okay, we will explain later. Week 9 or 10. Okay, converted to electricity. Geothermal energy converted the heat from the earth internal earth. Sometimes it's some thermal energy using the steam generated from hot water and converted to electricity. Biomass energy converted the organic material such as wood, any other waste material, okay, into electricity or heat through composition or decomposition, okay, converted to electricity or heat. And last, renewable energy sources, tidal and wave energy, convert the energy from ocean tides or waves into electricity using specialized turbines, okay, converted to electricity. Now, the USA now they have this hour. See the August 28. Now the time is 5:44, right? This time, okay? See, the demand, this demand, okay? We work on this next hours tonight, okay? This demand power, this generated power, 75 gigawatt, 75 gigawatt, okay? So the total, generation today, 75, started at 75 gigawatts, okay? And reached to around 90 gigawatts, now 90 gigawatts. Here, 90 gigawatt, 89.861 gigawatts, okay? Now, demand forecast for next hours, forecasting for next hours, or for next days, or for next week, next month, next year, next years. Okay, we can implement the forecasting power for 10 years. Okay, so but this 24 and today, for next hour, the power demand will decrease. Okay, the power demand will decrease here at 12 to 84 gigawatts. 84 gigawatts. Okay. Available capacity is generated. So the difference between capacity and the load demand, this area. This area. Okay. Grid conditions, excellent, both. Okay. I will discuss last one because this updated each 5 minutes. I will discuss later. Now, generation outage, 12.5 kilowatts, nothing, zero, one home, two homes, three homes, no problem. 12, around 12.5 kilowatts outage, okay, generator outage, but still the capacity more than the power demand, so it's fine, no problem. Now, this is very important, this is our class, this is our class. Fuel mix, see, solar,
Is this saying we generate more, power with, solar and wind and coal?
this is just renewable, okay, renewable, okay, and they added nuclear here, okay, coal, natural gas, and hydro, natural gas not renewable, okay, solar cell, see, the generated power around the 15.8 of the total power. This can at this point, okay, maybe tomorrow change, maybe next month will change. Why? Next month winter, no sun, okay. So maybe this will reduce and wind will increase more. Okay, depend on the season and depend on the days and depend on the city and the state, or okay, different. Okay, some see the wind and then prior view not same in Michigan as example, Texas not as in Michigan. Solar cell in Michigan less than the generated power Michigan for solar cell, less than Texas. Okay?
This one is in Texas or in US? This one
Yes.
is in the US or in Texas?
US.
Oh, US. So, most is natural gas.
Yeah.
The most, sorry.
Okay. Now, energy storage. What is mean by energy storage? Last Monday, today Wednesday, yes, not this Monday, last Monday, in Houston, opened this storage. New technology is coming on the Texas power grid. Now Houston has one, two. This is storage battery. Storage batteries. This is new technology. Last Monday, opened this one. Okay, and you can read this one. This. See, increase to when the power outage will supply enough to power 50,000 Texas homes during hottest summer days. Hottest summer days in July, June, July, August. Okay, almost in July. Okay. This is last Monday. It's open. This project done and installed all battery storage. Battery storage from where the input for these batteries from the electricity, from the solar cell, from wind, from gas, from anywhere. Okay, just store the electricity in the batteries, and when the system, the main grid out of the surface, the batteries will supply.
So there shouldn't be any outages now.
Yes. During storm or during okay, loading. So now again go to the renewable energy, or sorry, go again to the grid. Okay, this is energy storage resources. See this one, ESR discharge and charge and discharge. Okay, net output. This net output. Okay, and discharge and this discharge. Combined wind and solar. It's our see at this moment at the time now 5:52 or at 6 plus 12, 18, so approximately at 18, okay? Wind generator average, hardly average, and solar cell average, and combined generator hardly average, combine this one, okay, this one, this combined, okay? So now, when 8 giga, 8, no, 8,175 megas, so 8 giga, okay? And solar cell, solar generator 14 giga,
Okay.
or but solar cell, okay, they say solar cell 14 mega, oh, too much. Half USA people install solar cell, but we don't know what the disadvantage of solar cell. In this class, we will know what the disadvantage of solar cell. Maintenance, type of materials. Okay, so we will know all these disadvantages of solar cell. Cost, the cost, very important. Okay, we will install solar cell unit for warranty, with warranty 10 years. The price 25,000. Okay, 25 divided by divided by 10 years to 2,500 per year, divided by 12 months would be 250, around $250 per day. Very expensive. Okay, we will study the economic consideration for this type, for solar cell, for wind turbine, for hydro, this class. Okay, so now this one, solar per day. Okay, and here system-wide demand. This is auxiliary service as as frequency. Here, see the frequency now. Frequency now exactly 60.02. When I say 60.02 in Houston, Dallas, Michigan, all area of the USA, 60.02. If different means the grid isolated. Grid isolated. Okay? Isolated. The area of the of Texas and area of Michigan, or area of Houston and Dallas, area of Pryorview and Houston, or okay? Separate. But all the USA now 60.02 at this time. Okay? Any question, please? This is very important, and I like this.
There is the average.
Yes.
So ERCOT doesn't only monitor Texas, it monitors the whole US? Okay.
Most, no, about 95%.
Okay, but Encore,
NRG,
does Texas only?
yeah,
Okay.
NRG did the project with other department, but unfortunately it should be give lecture per week, 1 hour lecture per week with my class, but they couldn't offer
Yeah.
the speakers, okay,
Yeah.
last year, okay. So now this frequency, the frequency is very important, okay. Now, DC type flows or DC grid. We have DC grid. One project now, fund project I submitted about DC grid. Very important. DC grid is very important. Why? Because the stability is very high for the DC grid. Okay. We need DC. Where we need the DC grid? In trains, in lift, in charge of the car. Okay, charge now AC, but we need the DC to charge the car. Some cars we need to DC. So DC grid is very important now. See, because now out of the office, most people out of the office and all factories off the 6 o'clock. See the power drop to zero approximately. Okay, and this is divided to east, north. Okay, see here, 599 megawatt or 600 megawatts. Okay, around 0.5 gig or more than 0.5 gig at time at 12 or 2 p.m.
Mm-hmm.
Okay, but maximum around 6 megawatt per day. Okay, maximum. Okay. Weather forecast. Okay, sure. Weather forecast depend on the solar cell. All renewable energy depend on the weather forecast. So it's very important. It's very important factor. System-wide prices, these prices, okay. And if you want to extend it, market condition. Here, you can find all these figures up to the time. Or if you want the data in Excel sheet, current system condition, here, the forecast as an example. Okay, the forecast this one versus actual. This one. The forecast. Okay. August 28. It's actual and forecast. Forecast maybe yesterday or maybe last year. Forecast today was the power consumed by the load or power demand. And actual this forecast and system load, the system load green and brown, and they had forecast and they had SCL or this one. Okay, so because when we design power grid should be forecast the power, forecast the load, forecast value. Now, for 10 years, not same now. And after next year, the building will increase, the load increase, the stories, the homes, universities, expand the university. For 4 years, no engineering building. But now we have engineering building, new building. Okay, it's power, consume power. So should forecast the power after 10 years or 5 years. Okay, most calculation for 10 years. Okay, so now if you want generation as example, DC tie outage report, this one. Also, this posted 8-9 is all. Why? Because there's no outage power during this time from August 9 to today. No report. It's outage power. Okay, you can see the grid. Texas grid or USA grid, Houston grid from this one. Load, it's load. Actual load, forecast load, this one. Of today. Again, go to the picture. Okay, renewable energy. So we discussed this one or no? Wind or hydro, geothermal, discuss this one. Now, renewable energy and non-renewable energy. Renewable energy, wind, solar, thermal, hydro, tidal, but for renewable and non-renewable. Renewable power plant, these plants is hydro, solar, wind power, geothermal, biomass, tidal, and wave power. Non-renewable fossil fuel as coal, natural gas, oil. Okay, not oil for food, no, oil, food, okay. So oil power and nuclear power plant and diesel. Okay, it's non-renewable energy. Non-renewable energy group. Please type non-renewable. Thermal. Okay. These sources use thermal power station, thermal generator. Okay. Natural gas use gas station, gas power station, not gas power station. Okay. Gasoline used in small generator. now gas and thermal combine together or mixed together to work to generate power. Okay, so gas power plant with coal as example. Okay, diesel or emergency at near the hospitals or near the research center. Okay, they install diesel power plant. Why? Because when the electricity out of this surface, the power system, generator or transmission line, due to storm or due to loading, any fault, the hospital should be supplied by electricity all the time. Okay, all the time. No shutdown, no off. Why? See, the load divided to three categories. Categorize one, very important, as hospitals. Categorize two, important, not very important, important, as research center. Some research center, because some important research center classify as category 1. Why? Because for a nuclear category, nuclear research center, this is very important. If the power shut down, it's a big problem. Hospital, first category. Why first? Because maybe it's, some patients or operators or so should be or must the power continuous all the time. Okay, the power due to storms shut down. So the diesel power plant would work to supply the hospital or the important research center. Categorize the three loads. We are categorizing. 1 week, 2 weeks, no problem. Okay, but hospital and important research center is very important. So categorize one. Research center as a smart grid center in private. No problem if 1 hour, 2 hours, 3 hours is okay. Or lab in the university, no important, but no power for 1 day or 2 days, okay. Due to emergency condition, okay. So, okay. Diesel, diesel power near the hospital. Near the hospital, but there is time between the off of the main supply and on the diesel power or backup generator. We can remove this off period using an interruptible power supply, UPS. Connect UPS, large UPS. This large UPS consists of batteries. Charge the battery when the main supply on, then discharge to the inverter, electricity to inverter to convert the DC to AC to supply the hospital, and when the diesel start on, the UPS will be out of the service and continue the power supply. The hospital should be on continuously, no 1 second or millisecond off. Yes?
Are diesel power plants actually like power plants, or are they like just backup generators?
Backup generators, yes.
Okay.
This is backup generator.
Okay, not like actual like power plants.
Yeah.
Okay.
Okay. Hydro generator is base generator. Hydro represented as base generator.
Okay.
Okay. Any question, please?
So most of the like the backup generator in the houses here, it is diesel or what? Mostly.
Yeah.
For small
It is-
generator,
Okay,
gasoline, it's working on gasoline,
Yeah.
or sometimes on gas, okay? On gas or diesel, large, or three phase. Okay, so it depends on the size and rating. The size depends on the rating. Okay, now in market and Sons and Costco, there are two types of generators. Small size, the price of small size $400, $399, and other one $6,000. 6,000 is three phase, okay, large, okay, but this small one is generate 10 ampere, no more, while the three phase no generate 120 per phase. 120 ampere per phase. The large one working on the gas, no on the gasoline, while the small one, no, was gasoline. Okay, any question? Yes? Type of power station. Type of power station. Okay. Thermal power station. We will repeat same, but divided according to the renewable and non-renewable, or divided according to the type of fuel, or divided, but same. See here, thermal power station. Use the coal, natural gas, oil, fuel to heat water and boiler. Okay, producing steam that drive turbine connected to the generator. Nuclear power station. This is thermal. Nuclear with the thermal power station. Nuclear power station using the nuclear reactions to heat water, and producing steam. The water used in nuclear called heavy water. Heavy water, okay? Heavy water. Heavy water used in nuclear power station. Hydroelectric power station is utilizing the potential energy from up, when the water drop from up to down, okay? The turbine will rotate, okay? Or maybe store water, okay? To store water and dams, okay? Or kinetic energy of the found water in the rivers, okay? Turbine connected to generator. Now, solar power station, photovoltaic and concentrated solar power, CSP. Okay. Photovoltaic convert sunlight directly into electricity using solar panel made of semiconductor material, silicon. Okay? Silicon as example. Concentrated, concentrated solar power using mirror. The sunlight on the mirror, and the mirror reflects the heat to the boiler or to any water container, okay, to rise the heat.
So, which one stays on the roof, which is the photovoltaic is on the roof, it's always on the roof.
Photovoltaic
Yeah.
PV.
It's
Plant.
always on the roof. Because
Yes.
the concentrated solar power.
Yes, this is used, mirror should be located at place near the water tank. Why? Because the sun incident on the mirror reflected to the tank to rise the temperature, okay, to
So
to
cannot be on
boil.
the roof, the one, that one cannot be on the roof.
No, roof, not roof, homes, maybe in building or university or any location, not office, not the home. And the home is on the roof, just as PV,
PVs,
solar. Yeah, PV, so yes.
So, I guess why would there be two? Is it because like one's more expensive? Like TV is
Yes.
more expensive?
Yes.
Okay.
Which one? The second one?
See, generating heat to
PV is more
produce the
expensive.
steam and drive turbine. Okay, this turbine driven by the steam generated from the reflected of the sun to the tank. Okay, so
Okay.
not use this one. Some about 99% photovoltaic, and this is 1%.
Oh.
Okay. So this is into a complex process to do it. Wind power station. Wind power station is to convert the mechanical rotation to electric using induction generator, double feed induction generator.
Yeah.
Okay, double feed induction generator. So this is very important in Houston. The factory of the wind power in Galveston. Okay, Galveston. Okay. The long of I will explain the design of the wind power in details. Okay, because we have two types of or three types. The traditional power, wind power, and long wind power, okay, and tube wind power. Last year, one students designed, PhD students designed tube wind power, okay. I will show you his design, okay. This is very important. Maybe if you want to develop his design, so okay. You know, I think Oda, okay. Oda.
Olatunde.
Yeah.
He graduated, yes,
I know
last summer, not this summer, last summer,
Yeah.
last year, okay.
What
Dr.
you want,
Dr. Atiyah, Dr. Zaid, and I, within the committee of
How
this.
about maybe somebody working in this
Yeah.
department?
He worked in AutoCAD and CAD-CAM as software, then design software, CAD-CAM, then design hardware. Now, geothermal power station, heat, transfer the heat from the earth interior is used to produce the steam that drives, but this is how to be stay waiting, where is the steam goes from the interior earth and no, this is not, yeah, see, most power stations, succeed power station, in the USA, solar cell, wind, hydroelectric, thermals, okay. Geothermal is nothing, zero power. Biomass power station, burn organic materials like wood or any waste, gas or any produce, generate to electricity, and this is nothing power. Okay, maybe generated 20 kilowatt, 100 kilowatt, nothing. okay, with respect to 8 gig or 8 gig photovoltaic and photovoltaic 8 gig, 8 gig, okay, 200 kilowatt, nothing with respect to 8 gig. Tidal and web power station, tidal power station, this is from movement seawater, okay, to drive the turbine, okay.
But the back of when was they use similar other countries like Singapore, they use what they use.
And the turbine provide for this is a special turbine. Turbine rotate in 2 direction. Okay, 2 direction, clockwise and anti-clockwise. So, but in both cases generate power.
So
Okay.
what will be the frequency? What will be the frequency of the anti-clockwise?
Yes, it's the same frequency, but depend on the water direction. Okay, water sea here is seawater when come rotate this direction. When goes rotate in another direction.
Only
But the
just
power,
speed.
yeah, the power, the output power connected to the converter to convert the same direction power, okay, in both cases. But the rotation is difficult, okay, so we need special to,
So
special design.
The direction of the flow of water
Yeah.
will determine if it's clockwise or anti-clockwise.
Yes. Web power station, this is due to the energy of ocean waves converted to the electricity, and the fuel cell power station has chemical reactions and hydrogen or another reaction, and combined heat and power station, also one type of the power station. Now, why we need what time?
It's 6:23.
Right. Okay. We study these slides quickly to take break. Then after the break, visit the upstairs lab to show you the lab. Okay.
Yeah.
Now, why there is why is there a push for renewable energy? Well, renewable energy it's free. No economic, no required to economic dispatch study about this one. But now it's expensive due to for solar cell expensive. Why? Because the installation cost. Because the type of materials, bad type materials, some factories is bad, due to dust, due to the weather maintenance, so the cost will be high, so should be, if you want to install solar cell, you should be study the types of connection first. For connect to grid or off grid, on grid, off grid, or hybrid grid. Okay. This course we will learn what is meant by on grid, off grid, and hybrid grid. Okay. But now again, which one? Sure, hybrid grid will the supply, main supply will take power from you and they will pay for you, but this system is expensive. Okay. So first should be study the economic of the project. Now, if you install solar cell, the materials should be studied. The materials, what the long life for the life of the material maybe is bad factory, so no more 5 or 4 years and will be expired, because this is diodes and lead, okay, and lead and in Houston as example, high temperature reached to the temperature reached to 100 or more 100 Fahrenheit, so maybe the diodes will be expired for 4 or 5 years, no, for 10 years. When you go to the catalog, you can read the lifetime for the panel, but it's not issue. Maybe this is measured according to Houston, to Michigan or another factory, another country. Sorry, another country, or maybe the factory. Okay, not in the USA, Mexico or China or different. So the brand is different. The brand is based on the lifetime for the solar cell. So should be study everything, all factors before install solar cell. Wind turbine possible, you cannot install it, but for small wind turbine available in Amazon, you can install it, small. But I think it should be get approved to install. Okay. But it generate 1 ampere to. Now, so overview of renewable energy. We say wind turbine or wind power, solar cell, geothermal, hydro, biomass, and wind power. This wind power, we will discuss wind power in details next week. Okay? Design and types and everything. Okay? Solar power also we will study. We will start next week maybe study the solar power. Solar power we will start on the ideal circuit, practical circuit, equivalent circuit for the cell, okay, and design of the solar cell, design in general, and with factors. I will explain later what the factors in solar cell. Third, see here, the turbine. We put turbine here. This input or coming wave, then rotate in this direction, and when it goes, will rotate in another direction, but the generated power same sign, positive, negative. Okay, AC, but positive, negative. Geothermal energy, heat from plains to earth, heat, okay, and hydroelectric energy. This is very important because this station is base station, okay, and come from the energy come from the damp water, driving a water turbine and generator. Energy collect from the moving water. Okay, hydroelectric, see here, the water drop down, and this turbine, rotate the turbine, okay, rotate the turbine and generate the power. Okay, turbine is the mechanical part of the station. Choose up of the site should be turbine, okay, and site should be easily accessible. Hydroelectric plant classification according to the type of runoff river with edge, with point edge, without edge. I mean, as let me explain. This river with edge, and this river without edge. See it?
With
Okay.
an edge, yeah.
Yes. Or here, share some location maybe is this is not natural, okay? And input here, and this output, okay? Here, the follow of water from this side to this side, okay? Follow the water will rotate the turbine to generate power. There are two types of turbine, and if you use dams, then classified according to the height of the dam, maybe H more than 300 meter or more than 300, less than 300 meter, or low head 3 meters. I will explain later. I'm sure we will discuss the hydro power station in details. Okay, three types of renewable energy sources. We will discuss in details. Solar cell, wind, and hydro. Okay, and other types of renewable energy sources. Discuss just one for each source. Okay, but solar cell, wind turbine, and hydro. No, we will discuss in detail around each. Solar maybe 3, wind 3, and hydro 2. Okay, 6, 8. Okay, and other types. Other means 1. Okay, so according to the nature of the load, is base load, peak load, or pump load, but it's the hydro called base load. Okay, the base value taken from hydro, not from solar, or from the base value. When we say take the base value 100 megavolt ampere, this is the megavolt ampere of the hydro. Okay, because it's base station or base load. Okay, or base load, but it's work at peak load. But at peak load is sometimes it's difficult. Why? Because at peak load, the gates of the dam should be raised and time to response and but at peak load, solar cell we can insert to the grid, okay, to cover the power demand at peak time, during from 11 a.m. to 4 or to 5 p.m. Okay, we need more power. Okay, pump storage also. The main parts of hydro, the server, this one, this, okay, to receive the water, okay, and penstock, this penstock, drop the water through penstock. Okay, a prime mover here, and powerhouse to generate the power. Do you need this spec? Okay. the power generated from the hydro power station given by this equation, P equal 9.81 QH. Q the flow of the water per cubic meter. Flow the water, okay? H height of the drop.
The height.
Okay.
So 9.81 is from the gravity, right?
Yeah.
Nine, yes, it's
Okay.
constant, this is due to 9.81, and density of water 1000 and 75 kilogram meter second equal 1 metric horsepower for the British standard 0.7 36, but for the USA 0.746. Okay, we will use 0.746.
One was one, right?
Yeah,
3.4.
746.
746.
Yes, not 743.
Yeah.
743 for British standard, but for USA, no, 743. Okay,
That's
so
0 point, huh? Right? Is it point?
0.736 kilowatt, so or equal 736 watt.
Multiply.
Each one horsepower equal 7 4 6 watts. Okay, if we have 10 horsepower, 10, so HP 746 times 10 equal 7460 watts.
Watts.
Okay,
So, for 0.7 times 4 is metric.
yeah, one metric horsepower, yes, equal point 736 kilowatt or 736 watt, or we say 746 our standard. Okay, so now this server, okay, and here down, and I get up or down according to the power required, and here the flow of water, and here the turbine. Okay, turbine, and then this turbine connected to the generator. Okay, this system called turbo generator. Turbine and generator, turbo generator. Okay. So now the load generator this load is power P generator or equal P electric or equal P out, same, power out, power electric, power generator, okay? This power delivered to the load by P demand or power load, P demand. If the load need more power, okay, need more power, so the power this one will be changed to delta P demand. So here delta P generator. But we say energy not created. Energy should be
Converted.
converted from one form to another form. So the generator connected to the turbine or prime mover, and prime mover connect to the control circuit. Control circuit will give alarm to the gate of the dam, this dam, and this gate, okay, to open, to follow more water. More water means more rotation, more generation, no more power generation. Okay, then, okay, more generation, this water, okay. The load will take the more power, but if the load this increase the power, if decrease power load, the gate will be closed, okay, will be closed, okay, or goes to down, okay, will be closed. For if the load need power, the gate will be open, more open, okay. Same concept for the thermal. For the thermal, no dam and water and no, we'll connect it to the valve and open the valve to follow more steam to generate more power. Okay?
Okay.
Any question?
Oh.
No?
Oh, I have a question now.
Yes.
So the control circuit need electricity go to it first, right? Or is that how it works? It need electricity for the control circuit?
Yes.
Okay.
Yes, sure. Hydro, all power station control circuit.
Okay.
Control circuit is here to open or close the gate. For the thermal, control circuit to open and close the valve to enter to follow the steam, more steam or less.
Okay.
Okay.
But power needs to be supplied to the control circuit first. Right? Okay.
Okay. Any question? Now, so the power will 9.81. Okay, let me
There should be W there.
Q, this is Q. Okay, and high, this high. Okay, or high, this high. High up, down, or high. Okay, this high. So it will 9.81.
And that one, that should be W, right? QWH.
For the law, the units, for energy,
No,
For
for
power,
energy,
for power.
energy,
Yeah.
any energy equal power time, time, time. Okay,
Yeah.
so this one power multiplied by time to produce the energy, yes?
Yes, for the power, that should be W, right? 9.81 QWH. W is the density of water, just like the one on the top.
Where is
The
density
formula.
of the water, no, W density of the water
Yeah, and the power over there on the top, QWH, right?
No, see, 9.81 times
Oh, yeah.
10 power minus 3,
Okay, okay.
QWH. W 1000, density of the water.
Oh, okay, I get it.
So
Yeah.
1000 times 10 power minus 3
So
equal
it's
1.
a bit, yes.
Okay?
So where did the constant come from?
The constant, this is, see, 9.81 relation of the density of the water, okay, of the water in the station. Okay. So this is constant.
That is from the potential energy of the.
Potential energy, yes, related to potential energy and different energies. Okay, so equal 9.81 times also gravity, all factors put in this constant. Equal 9.81 times 10 power minus 3. This minuses.
Yeah, that's right.
Yes, yes, this minus, okay?
Okay.
And then multiply by 1000 kilogram per meter, per cubic meter
9.8.
is the density of the water,
Mhm.
is constant also. So 1000 times 10 power minus 1, so would be 9.81. Okay, and this is also depend on each 75 meter second to 1 metric horsepower converted to the horsepower. That includes all these factors in 9.81 milli or 10 minus. Okay, but we need this equations power equal 9.81 times Q times H. Okay, and energy times time T time. Example, we will study this example in details next time. This is river has a discharge of 5,000 cubic meter per second with a head of 15 meter. Calculate the power generated. Power generated given by 9.81 times Q times H. So we have Q 5,000, we have H 15 meter, then multiply to get 75.75 kilowatt. If the overall efficiency is 70%, calculate the input power to the turbine. Input power to the turbine, what's the input? What's the type of the power?
Mechanical.
Input to the mechanical, right?
Mhm.
Okay, mechanical power. Mechanical. We have output power.
It's electricity.
Okay, calculate the input power. Output power, we calculated output power from where? From 9.81 QH. We calculated output power. Okay? Then input power, we have efficiency equal power, output power, and so power and the 10,051 kilowatt.
Mhm.
See, the efficiency is 70%. The efficiency of the solar cell 25%. The wind turbine 50%. The efficiency is low. But when it's connected to other sections, the overall efficiency will increase. Why? Because as example, if we connect solar cell with DC chopper, the efficiency of DC chopper 99%. Multiplied by 25 will rise the efficiency because multiply it together. And connect to the inverter. The inverter efficiency of inverter 95. Increase that. Okay. So you will take the overall efficiency. Okay, not just the, but for solar cell, no, 25. And one PhD students modified to 26%. Okay, last for 3 years. Modified the efficiency from 25 to 26. This is maximum efficiency. Okay, so now the efficiency of hydro 70%. We can calculate power. Find the kilowatt hour.
The energy from the water is the input, right? Not the output. Because
Water and yes, input.
yeah, but why it is the power generated is
Yes,
the output.
because this formula is the power electric, not power mechanical. Power electric. Okay. This formula gives the power electric, not power mechanical. Power mechanical we cannot calculate power mechanical.
So that like the energy comes from the water, right? And that is the input, and the output should be less, right?
This power electric output of the generator. Okay, while power input to the turbine, from where? From the water.
From the water.
But the output power, electric output power from the generator depend on the head of the dam and depend on the. Make sense?
Okay. Let's see, let me think. But what I mean is the energy from the water is the input, not the output, right?
Yes.
But why it is
Yes.
why it is
yes.
output? Why 735 is the output, not the input?
No. This formula for electric power,
Okay.
output electric power from the generator.
Output electric power, okay.
Okay?
Okay, sure.
1 minute.
It's the output because it's the electricity.
See?
Okay.
Power out given by the formula 9.81
Okay.
QH. But this formula depend on the water
Yes.
here.
Okay.
Okay?
Yeah.
But the water generates power mechanical. This power input to the generator, and this is power out. Make sense? Okay, but
Okay.
this power depend on this one. Okay, the
Okay.
mechanical depend on this one. The difference between power out and power in given by efficiency. Okay?
Okay.
So power now power generated, sorry. Power generated. The generated energy equal power out times T, we say T equal 20 hours, so 20 full kilowatt hour. Any question?
And the input power also from the water, right? The input
Yes,
power to the
yes, but mechanical, not electrical. Input to the generator, mechanical, from the turbine.
And the input power is also from the potential energy.
Yes,
Okay.
yes, affected by potential energy, but we cannot to calculate it because it's mechanical. So from where we can calculate from power out and efficiency. We have power out, we have efficiency, so. Okay. Do you need this one? So now, tidal power work by building, this is not used in the USA, future site, England and USA, because it's very expensive and we need a special turbine to generate power for tidal power. So this down. Biomass energy. This biomass is renewable energy also from plants and animals. There's nothing general power, but nothing. Biomass conversion. This one and conclusion is 18% renewable energy by 2024, and the short-term energy outlook on solar cell will rise slightly according to 16 of the total generation in 2023 and 18 last year 16%, this year 18% or 20, maybe 20% now is 20. Okay. Renewable energy target are being set to the US government now. And this is the comparison between different renewable energy sources: solar, wind, hydropower or thermal, biomass, geothermal, tidal, and wave. Benefit for sellers widely available. When it's clean, cost effective, cost is high. Okay. See some samples, no mention to the cost of the solar cell, but solar cell high cost, high cost. Okay. If you compare the solar cell installation and maintenance on everything during 10 years with the bulbs for 10 years, okay, from the traditional power, the bulbs from traditional less expensive than less than the cost of the solar cell.
The most expensive is the material, right? The material is expensive.
Yeah, material expensive, installation expensive, maintenance expensive, everything is everything is expensive. Because if you call any company to do maintenance to clean the so, yeah, well, should be paid 100 or just to visit your location. 100, and then start to clean
Estimate the cost.
It's for,
Yeah.
for one house, for
one house or for factory or any location. Okay, so it's expensive. Okay, high initial investment and weather depend efficiency and efficiency around 22%. Okay, but the wind turbine 45, but we cannot install 40 because each unit is more than 10 or 15 million dollars. So this is just large companies or government, they can install the wind turbine. Okay. Hydropower, also hydropower, we cannot, but the efficiency is 90%, okay? And limitation, high infrastructure costs of the done concrete and around 50 or 40 gates, okay, all gates controls and gates from concrete also. So it's very expensive, very expensive. The installation very expensive and the maintenance very expensive. Biomass is utilized waste material. Okay, but is the efficiency 25, but the power generation is nothing, it's very small. Okay, and geothermal, high efficiency and reliable, low carbon footprint and high initial cost. Geothermal region and the efficiency 20%. Double wave is long lifespan, but limitation is higher initial cost because we need special turbine and special generator for this one, and efficiency between 30 to 40. Okay. These curves show the uses of the power sector between 2018 to this year, okay, annual share of the USA electricity generation for natural gas, for nuclear, coal, wind, hydro, and solar. The solar increased, but the wind turbine, the wind more, okay, hydro average, nuclear in average, coal is decreased now, and gas, most generation power in the US, natural gas. What is the microgrid? Now we need to integrate the renewable energy with the microgrid and with the smart grid. What is the microgrid? Microgrid, main grid. Microgrid is the small grid or micro part of the grid. Part of the grid. But this grid includes generators, loads, distribution system, transmission line, etc. But because it's at the distribution side, I mean 12 kilovolt side, low voltage side, so we can't connect this wind turbine, solar cell, or renewable energy sources to microgrid. So we will integrate the renewable energy with the microgrid, okay, and then we can control by smart grid, because smart grid is the communication between the parts of microgrid, and and smart grid is the communication between microgrid and the traditional grid. Okay, so application for this one, or most of the operation operate connected to the grid or island mode, maybe connect to grid or island grid. Okay, on grid or off grid. Distributed energy resources includes local generation, often closer to user, and energy sources past use fuels as gas or natural gas, or oil, or any fuel cell fuel. Application: power critical facilities during outage, service hospitals, universities, or any defense load. This is grid, okay, and it is the microgrid manager, manage the natural gas, see here, natural gas fuel cell, and here backup generator, diesel as example. UPS connected to hospital. Renewable energy storage. See, the microgrid consists of the traditional power as gas or diesel generator and renewable energy sources. Sometimes small thermal units, okay, and connected to the grid, supply power to the grid, and controlled by microgrid manager or by smart grid system. Smart grid system. Smart grid system is the communication between the or among the components. Okay, communication among the components of the microgrid and the main grid. Main grid or utility grid or national grid or infinite bus bar. The power system we call it infinite bus bar. We will discuss later what is meant by infinite bus bar. Okay. Several variation or combination of microgrid are possible. Number of customers. Microgrid depend on the number of customers. Okay. Not microgrid, maybe the grid in Houston or a grid of Prairie or a grid or small area. Okay, so, serve of small area, not large area. For as example for Texas, Texas grid is not microgrid, large grid, okay? But for Prairie View, we can install microgrid at Prairie View or at multi-microgrid Texas, okay? But the total grid is no, it's main grid, okay? Or national grid. Load types and functions, we know we have different load, dynamic load, static load, and static load. Maybe light load, maybe lagging, leading, okay. Also connection type, off grid or on grid or hybrid connection, okay. These factors affect on the microgrid connection. We will discuss on grid, off grid, maybe next week. Okay, microgrid provide tiny fraction. USA is now. See, in the USA, 2016 was 1.6 gigawatt, while now around 8 gigawatt. Now 2024, 8 gigawatt, okay? And 2024, okay? So most microgrid projects in Alaska, California, Georgia, Texas, Oklahoma, New York, okay? And microgrid are attractive for many large of US companies, energy or air cut function. Benefit of micro grid, okay, when the main grid out of the service maybe will generate power, okay, so to keep the electricity continuous to the load, okay, the electricity continuous with the load, no shutdown effect on the load, but sometimes same microgrid is shut down. It depends on the, but how to keep this grid on and main grid off, because solar cell no need to cables or towers Okay. Last storm, the problem in tower support of the transmission line. When the towers failed, so the transmission line maybe cut or out of the surface. So this effect on the generator, because out some units of the surface, because the frequency of the generator rise more than 60 hertz, more than 61 or 62, so the generator will be shut down. So, but no transmission line connected for the solar cell. Solar cell locally you can install at home or any location. No shutdown. Yes. So, and during the emergency, bad weather or anything, if the electricity out of the surface, this grid, solar grid, can deliver power to the main grid. Okay, to main grid. So this one benefits, it's very important. Also, my grid is zero emission electricity. Wind, no emission. Wind turbine or solar cell or hydro, no emission. So it's friendly to the life. Microgrid can improve local management of power supply and demand. Also can enhance the grid reliability, grid security, grid efficiency. Okay, the microgrid increase or improve the security or cyber security of the system. Why? Because we will protect it or against the attack. Okay, or increase the reliability. How to increase or modify the reliability, develop the reliability. Reliability means if the power system out of the surface, main power system out of the surface, the microgrid will be supply power to the grid or to the load. Keep your backup facility power on during the grid outage and store the electricity and sell it back to the grid during peak demand. During peak demand, we can inject power from the solar cell or from the wind turbine to the main grid. Integrate on-site renewable such wind and solar. Now conventional grid and smart grid. Conventional grid as electromechanical, but rotation. Okay, but smart grid is digital. Digital because it's controlled, scaled, on off, just on or isolated part. Isolate the main grid or isolate the generators, isolate the wind or isolate any part due to the maintenance or due to the fault or anything, digital. Conventional grid is one-way communication, while smart grid two-way. We have application upstairs. The application of the upstairs, we can control the system, smart grid, by using the SCADA or manually. Manually one way, but SCADA we can communicate the computer with the hardware using PLC. PLC design using PLC, then converted to SCADA. Okay, the centralized generation and while the distributed generation. All generator connected to the microgrid called distributed generator. Why distributed generator? Because the voltage level of the microgrid equal to the distributed voltage. Distributed voltage around 12 kilovolt, 18 kilovolts, okay, not high voltage. While the conventional grid, no, centralized generation is 33 or 66 kilovolts at the transmission line. Manual monitoring, conventional, and a few sensors, while high sensor for smart grid and self-monitoring, manual restoration and self-healing, and failure and blockage, adaptive and islanding, limited control, while pervasive control is vice control. Few customer choose and many customer choose here, because now most loads connected to the smart grid. You see when the electricity out or off, electricity off, direct after 1 minute or 2 minutes, okay, turn on, okay. No need to call anyone or any company or direct, okay, and without any maintenance, direct automatically return to the service. Okay. Traditional grid and smart grid, again customer calls when the power goes out, while the smart grid automatically return to the service. Alternatively, peak load, but in suppresses peak load, this lowering the cost, and difficult to manage high wind and solar integration, while the utility can manage distributed energy resources sector. Okay, oh, 7:18. So we don't have time to see that today. Next week, no problem. 10% power loss for TD, traditional grid distribution, while the power loss is 2% smart grid. All centralized control, local center control, provided distributed generator. I think this is comparison between smart grid, microgrid, and conventional grid according to the reliability terms, security, renewable integration. For smart grid, high reliability, high security, and renewable integration possible, while for microgrid without smart grid, just microgrid, medium reliability, intermediate security, and possible to renewable to integration already, because wind turbine or solar cell integrate direct with the microgrid or smart grid. But for conventional grid, possible. Okay, but it's difficult. Okay, to connect to the main grid. Low reliability for the conventional grid and very low security. Very low security. Monitoring and control, sure, smart grid is easy and fast monitoring and control. Microgrid easy and moderate, not fast, but not easy combination. Okay? Because smart grid is a new technology. As meters is smart grid. Okay? Meters, smart meters. Okay? Smart meters. The grid. Emergency response very high for smart grid, high for microgrid, low for conventional grid, and electric telecom integration, sure, smart grid integration, microgrid is electric vehicle integration and possible, but with few changes. So for this reason, we can implement smart grid to charge the electric car. Okay, using smart grid and microgrid. Okay, we implemented DC grid to charge the car. Energy storage option for all, yes, and differences in energy trade, very high, low, interoperability, yes, difficult, okay, and power quality issues, yes, but it's difficult for smart grid. Moderate for microgrid, high for conventional, all conventional issue, and operation efficiency high, and medium for conventional grid. Now, last power system, we say economic dispatch, but today, no, with the smart grid and renewable grid and renewable energy and micro grid, we will say energy optimization, system optimization, demand optimization, delivery optimization. All just economic dispatch optimization. That's it. Today, see, the power system developed by microgrid and smart grid. Okay, developed. The first generation and transmission management, transmission automation. That's it. But now, sensors, distribution management, distribution attenuation, advanced automation, advanced metering system, all these components added to the distribution system. Generation delivery, generation line, substation, that's it. But now they insert distribution equipment, voltage control, and renewable generation. The power system is below. See all the grid is all the new grid or modern grid. All these terms added to the system, okay, due to the smart grid. Smart grid solution of this one and sources, energy of sources. See here the curve is solid fuel, liquid fuel, natural gas, hydro, and nuclear. This is for non-renewable, except hydro is renewable energy. Okay, sources. Implication of our station should be near the load center. Should be the building located at the on the cheap land, not expensive. So if we want to design microgrid, not design at downtown, design prior view or on the college station. Why? Because the price of the land is cheap. Okay. Any question? I'm already uploaded this